Okay, so now let's move on to the first method of factoring trinomials whose leading coefficients are not equal to 1. Okay. The first method is called decomposition of the middle term. So what this method is really about is we can rewrite a trinomial whose leading coefficient is not equal to 1. For example, ax squared plus bx plus c as the expression I wrote after the equal sign, ax squared plus mx plus nx plus c. So the reason why we rewrite bx as mx plus nx here is because there is a very interesting property of trinomial, okay? So if we write m and n like this, okay, m times n will be equal to a times c. And at the same time, m plus n will be equal to b. So these two conditions help us find the values of m and n. Okay. This might be a little bit confusing. Actually, I had time to go over one example in my morning class on Saturday, but I didn't have time to do any examples. I didn't have time to introduce this at all in my evening class. So I'm just going to start from the beginning and give you an example, okay? So we see what this process, like how this process goes. For example, so remember here we're dealing with trinomials that look like this, okay? And a is not equal to 1 anymore, okay? A is not equal to 1 anymore. So let's look at this example. For example, 3x squared plus, let's say, 7x plus 2. I just made this up. Okay? Yeah. So let's see how we can factor this trinomial. Okay, so here, pay attention, please. Here, a is equal to 3, b is equal to 7, c is equal to 2. Okay. So we want to rewrite this trinomial in the form of 3x squared plus mx plus nx plus 2, where m plus n is equal to 7, and m times n is equal to a times c, which is 6. Okay, so we are looking for two integers that satisfy both conditions. M plus n is equal to 7, m times n is equal to 6. The answer should be quite obvious. The answer should be m is equal to 1, n is equal to 6. Okay. Like I said, whether you say m is equal to 1, n is equal to 6, or m is equal to 6, n is equal to 1, does not matter here. Okay, it doesn't matter here. But the answer for m and n is 1 and 6. So now we can plug the numbers back into our expression and see what we can do. Okay. So here, the expression, the trinomial, now is equal to 3x squared plus m is equal to 1, so 1x, n is equal to 6, so 6x plus the coefficient. Okay, so 1x is just x, so we can just erase this. Okay, so now what can we do? We can group these two, we can form these two groups by grouping the first term and the first two terms and the second two terms. Okay, and now we can factor the common factor out for both groups. For example, 3x squared plus x. What's the common factor for 3x squared plus x? The common factor is x, right? So we can factor x out, and there will be 3x plus 1 left in the brackets. Plus, for the second bracket, what's the common factor? The common factor of 6x plus 2 is 2. So we can factor 2 out. And 3x plus 1 will be left in the second bracket, right? And now we have another common factor. And now what we need to do is to factor this common factor out of this whole expression. So we factor 3x plus 1 out. X plus 2 will be left in the bracket. And this is our final answer. Okay. So the whole process, these steps are closely related to our factoring 1. So I think it was before the exam, like polynomials, factoring 1, how to factor polynomials from a polynomial. So whatever we're learning today is closely related to what we learned a few weeks ago. Okay, so if you have trouble understanding what I'm talking about here, it might not be because you don't understand this process. Maybe because you didn't understand how to factor a polynomial or a binomial out of a polynomial. So if you have any trouble understanding this, please let me know, okay? And I will tell you which section you should spend some time reviewing. But anyway, this process is called decomposition of the middle term.